Okay, good morning. There is another part of the lesson that will be in the exam as well. So you know that next Tuesday we will have the first exam, yes? As now, algebra and factorization. That's also a very, very important topic in algebra, but we will complete it mainly in Math 2C and 3C. So, but I want to just get familiar exactly at the level of the book. What do we mean by factorization? Okay. Of course, factorization, we have already talked a little bit about that when it comes to numbers. When I say factorize a number, I mean to write that number as a product of only prime numbers. Okay? So, let me make this clear, because there are two things when it comes to factorization. First of all, understand what is the meaning of factorization in general, and then of course how to learn to factorize polynomials. And that's quite a hard lesson. So there is not a very straight way to factorize all kind of polynomials, yes? Yeah, so you have, but you don't need to be worried about that, because at the level of the book, and they are supposed to, at the level that you are expected to know, is not that hard at all. And especially Math 1C, it's very, very simple. So when I give you a number, say for example 12, when I ask you to factorize this, I mean write this as a product. That is if I want to give a short answer. When I ask you to factorize this, I do not mean to write it as 10 plus 2. Of course 10 plus 2 is indeed equal to 12, but this is not a factorization of 12. You have written 12 as a sum. Yes? Okay. So when I say factorize 12, I do not mean write something like this. I have decomposed 12 into two summands. One of them is called 10, the other one 2. But this is not what I mean when I ask you to factorize. When I ask you to factorize 12, I mean write something which is equal to 12, but this new thing is in a factorized form. It is a product. So then of course you can write it as 3 times 4. Yeah, so that is a factorization of 12. I would say that I factorize 12 into 2 factors. These are the names. One of them is 3, the other one is 4. When I write 12 is equal to 9 plus 3, these are not called factors, they are called summands, yes? Okay, so when I say factorize, I mean write this as a product of 2 or more factors. Okay? But there is another thing implicit in the word factorization. When I say factorize 12, if you write this technically it is right, but I will not consider it complete. When I say factorize, I mean write this as a product in a way that no of those factors can be factorized more. Okay? So this is the way, this is always implicit in the word factorization. So you have to continue factorization until it is not possible anymore to factorize any one of those factors. So this means that 3 is a prime number. I cannot factorize it more. I can write it as 3 times 1, but it's just, we don't write. But for 4, I can write what? 2 times 2. So when I say factorize 12, even though technically that is also correct, but what I mean that I want you to write this. Of course, this is not unique. The only difference is that you can change the order of the factors. But in principle, no one writes like this. People usually write 2, appears 2 times, and then multiplied by 3. So when I ask you to factorize 12, I mean this. But if I want to give this in a short way, factorize means writing that expression as a product. That's it, okay? Now let us go to algebraic expressions. We can also talk about factorizing algebraic expressions. For example, I can give you this 2x plus 10. This is not a number. This is in algebra. It is an algebraic expression including one single variable, which is x in this case. When I ask you to factorize this expression, I mean to write this expression as a product. Okay, can you just do it in your head? Can you give me an an expression which is on the one hand equal to this, and on the other hand it is a product. What can I do? Yes? That's easy. So I just want to tell you that the idea of factorization is quite simple. So everyone hopefully agrees that these two are the same. We have already studied that. If I ask you to expand this, you would say 2 times x plus 2 times 5, which is 2x plus 10. So this equality is indeed right. But if I ask you what is this, you would read it as the product of 2 by x plus 5. So that is indeed a product. Yes? So I was able to write this as a product. Okay? So I would say that I factored 2 out from this expression. Okay, so this is the idea. You have to reverse engineer what we have done before. You remember in the previous lessons, I would have given you this, and I would have asked you to expand that. Then you just take this and multiply it here. So in some sense, factorization is the reversed process, which in principle is much, much harder sometimes. Why is that? Because it is sometimes harder. Because when you expand, there are some terms that are cancelled in the simplified version. And if I give you that one, it is very harder to immediately imagine which terms are the cancelled ones because they are not there. Okay? So just, I want you to understand the difficulties in front of us when we want to factorize something. Yes? Because when they give us an expression, they give us in the simplified version. We don't know which terms are cancelled. Okay? It is very hard to guess to go the other direction, but not for these kinds of problems. They are very simple. Even without teaching, you were able to factorize it. So that's the factorization. But can I continue further? One more thing is also important. If someone writes this, that is not, by the way, let us check. I want to ask your opinion about that. I take 3 out. Okay? And then I would write 2/3 x plus 10 over 3. Is this equality true or false? Let us check. No, it is not. It is not false. If you multiply this back, you should be very quick in this. Multiply 3 by 2/3, it becomes 2x. That's correct. If I multiply 3 by 10 over 3, it becomes 10. So this is still true. Is it a product?
Yes.
Yes. Is it? So this is true. Is it a product? Yes. So in principle, you might say that this is also a factorization. Because first of all, it is true. Secondly, it is a product. And then the question is that, is this the factorization of that, or this is the factorization of that? The answer to this question is also very important. The answer to this question is that by default, okay, when I ask you to factorize, I want you to work only with whole integers. Okay? So here, the numbers involved are 2. Here, the number is not written. The number next to x is 1. The number here is 5. These numbers are all integers. They are whole numbers. But here, these 2/3 and 10 over 3 are not integers. So this is important. When I ask you to factorize, I mean by default work on the set of integers. So you are not allowed to write this. If I want you to do this, then I have to extend this beyond the integers. I might say that, okay, work with the rational numbers, the fractional numbers. But I just want you to understand this, but all the questions in the book, you are dealing with this one. So I want you to understand, if someone tells you, is this a factorization? I would say, yes, it is a factorization, but if you allow me to work on the set of rational numbers. Yes? Is this a factorization? Yes, if you allow me to work only on the set of integers. And by default, when I do not mention that, which I will not in this course at all, by default, I always mean integers, whole numbers. So this is why, finally, I accept this one as the factorization. Okay, so that is the idea. Okay, and I want you to give I want to give you some examples so that we can factorize expressions. Okay, for example, I want to have x squared plus 2x. I want to factorize this if possible. Okay, can I factorize it? The best thing at this stage is to guess something so that after the multiplication is done, I get this. Anyone else? Can you guess? So what's the answer to this? Yes, I don't think it is that hard to guess what you need to do. So what is the terminology that I use? I would say that I take x out, or I factor x out, and then you need to double check all the time that this is correct. You multiply this back. X times x is x squared. Yes, that's correct. X times 2 is 2x. That's correct. So why this is a factorized form? Because it is written as a product. If I want to read this, I will read this as the sum of x squared with 2x. But if I ask you to read this, you would say this is the product of x by x plus 2. So if you want to read this, you read as a sum. If you want to read this, you read it as a product. Whenever you read your expression as a product, this means that this is in factorized form. Is that clear? Okay, so that is one idea. But to be honest, if this is a little bit complicated, so you might ask yourself, how can I understand what I can pull out? In this case, it was very simple. But what you need to imagine that x squared has two factors in it, x and x. And 2x has also two factors in it, 2 and x. You see that there is one factor in common. Yes? And that is the one that you have to pull out. Okay? So I pull x out. Yes? And then what is left from here is x. I pull x out. What is left from here is 2. And I write them. And I want you to know that the process is division. When I decide to pull x out, in my head, I have to divide x squared by x. But this was so simple that you were able to do it in your head. The answer is x. You write it here. And again, you take 2x and then divide it by x. It was so simple, you did it in your head, but this is the rule. So that is x times x plus 2. Okay, for example, let me just give you another example. If I give you this, and I ask you to factorize it, if you write this, let me ask you, is this true or false? Is this equality true or false? Whenever you want to answer this question, you would tell me, okay, Babak, wait a little bit, let me just do it the other way around. I multiply x by x squared, it becomes x cubed, true. X times 2x is 2x squared, that's true. So this equality is true. But if you write this for factorization, I am not saying it is totally wrong. Yes, this is a product, but this is not complete, yes? Yes, that's what I'm saying. So if I ask you, is it a factorized form? Yes, it is a factorized form, but that is not what I mean. Because x, you could take more expressions out. So if you write this, even though technically you haven't done something wrong, you have written something which is equal to this, and it is in the product form. But it is not acceptable because I would say it is not complete. How should I know that it's not complete? Because when I ask you what are the factors involved only in here, you would say 3 x's are involved. If I ask you what are the factors involved here, you would say one of them is 2, and I have 2 factors of x. How many of them are in common? 2 of them. So you have to pull 2 x's out. Yes? So you have to pull x squared out. When you pull x squared out, from the first term x is left, and from the second term only 2 is left. So between these two, you have to write this. And then if I multiply this back, so x squared times x is x cubed. X squared times 2 is 2x squared. But this is what I want you to write for me if I ask you to write this in the factorized form. Is that clear? Okay. And some students, for example, I have seen, let me ask your understanding here. So if I write x squared plus 5x plus 6, if I ask you, I will not talk about these things, but I want you to understand. If I ask you to factorize this, and you answer me like this, If you are the teacher, should I give the points to that student? If I ask someone to factorize this expression and I see that person has written this in the paper, okay, so let us check this. First of all, tell me, is this equality true or false? That is true. Why? Because you would say me that, be patient, let me multiply it back. This is our old lesson. Do you remember? We solved much harder problems than this, so this should be very easy for you by now. If I ask you to expand that, you multiply x by x becomes x squared, you multiply x by 5 becomes 5x, and you add 6 to it, which is exactly this one. So that is true. Okay? But is it in factorized form? Is it a product? Or is it a sum? If you want to read it. Yes? No, even if I write, so that's another thing. So let me write this 3 times 2. Okay, but then I ask you, is this a factorized form? No, the mathematics is very unforgivable, black and white. Either yes, 100% or no 100%. Or we don't know, of course. But the answer will be, again, either a definite yes or a definite no. So this is the question. Is this true? 100% yes. But is it a factorization of this? Yes, no, but I told you that if I want you to read this, how do you read this? You would say this expression is the sum of this and that. You don't read it as the product, yes? You read it as the sum of this product with this product, but you start with the word the sum, yes? So that's the sum. Understandable or not? Yes. So even though this is a true equality, but I want you to understand this is not a factorization of that expression. Then the question is that, is there any way to factorize this? I do not want to answer these questions in this lesson. We will study them a little bit in Math 2C and in more complete way in Math 3C. But this, I want you, at this level, you need to understand that this expression, even though is 100% equal to this one, but it is not considered as a factorization. So you cannot say that I partially factorize that. There is no partially factorizing. Either you factorize or not. But for example, let me ask you this question. Do you think that this is a factorization of that or not? I write this expression, and I write it as x plus 2 times x plus 3. I ask you this question, is this a factorization of that? The first, let me just write 1 here. Is this a factorization of this? Why is that? They are not equal. Even though the right-hand side is a product, but it is not equal to this. How should I know that? I just do the reverse process. I multiply this in my head, x times x, x squared, so far so good. I multiply x by 1. So let me just do that. So this becomes x squared plus x plus 2x plus 2. But if I add them, what happens? Which is not this one. That's not correct. Okay, now what about this one? This one is true, yes, because if you are patient and multiply that, it becomes x squared plus 3x plus 2x and then plus 6. And this is why you say I told you that this is sometimes very hard, because you see this 5x was actually the simplified version of 3x plus 2x. So either we should be able to guess the correct form before simplification, which is not in principle possible if the number of terms involved is so huge. Yes? So that's what I'm saying that. But anyway, if I give you this in the exam myself, I am not allowed to ask you to factorize this at this level of Math 1C, but if I give you this in the exam and I ask you, is this a factorization of that, you should be able to answer this. You would say that yes, because firstly, if I multiply that, it becomes this. Secondly, this is written as a product. These are the things. I want you to understand that. But we will not talk about factorization of these types in this lesson. Okay? We only think about these kinds of factorizations, that you have something in common in all the terms involved and you are supposed to pull that expression out. Yes? So let me give you some examples and we just do it together. So a squared b plus ab. I want to factorize this. Okay, so again, the best thing at this level is to write something which is in product form and the answer becomes equal to this. So can you guess? So what are the common factors? A appears 2 times here, appears 1 time here, and B appears 1 time. So what are the most common factors? The biggest one. I want to pull as much as I can out, okay? From A point of view, I have 1 in common, and from B point of view, I have 1B in common. I cannot pull more than these out, yes? So what happens? So you need to divide in your head. A squared B divided by AB, so B and B are cancelled. One of these A's are cancelled. So what is left for me is A. Of course, I want you to do it faster. You don't need to explain these details. It's preferable to do it in your head very fast, okay? And then I have a plus sign. Can you tell me what? 1. I have seen some students, I don't know, for some reason they write nothing. Because they would say that there was AB. I pulled AB out, so nothing is left. This is a wrong statement. There is nothing. Here nothing means 1, yes? Because you are dividing. Yes? So that is the correct one. So how many factors are involved? Let us practice a little bit with these words. How many factors are involved in my factorization now? How many factors are involved in the answer? No. 3. One of them is A, the other one is B, and the next one is the package of A plus 1 as a whole. Yes? So A plus 1. So this is also something I want you to understand. A plus 1 is similar to prime numbers. I cannot factorize them more. Okay? So this is somehow similar to number 3. If I ask you to factorize 3, what can you write? You just write 3 because 3 is a prime number. So that's also the case. I cannot continue factorization for A. I cannot continue factorization for B. I cannot continue factorization for A plus 1. So that's the end of the process. Okay, another one. Yeah, try to do it a little bit fast. So 5acx plus 15cx. I want you to factorize this. So what is the highest common factor that I can pull out? I would say that let us think in some steps. Between numbers, what is the highest number I can pull out? 5. So yes, because 15 is just 3 times 5 and 5 is just 5. So the highest common factor is 5. From A point of view, I do not have A in common. A is in here but not there, so it is not a common factor. I cannot pull it out. But C is here and there with the highest power, which is 1, so I pull 1C out and I pull 1x out for the same reason. Okay, can you tell me what is left now? From here, A is left, and this is a sum. And if I divide this in my head by that, 15 divided by 5 is 3, C divided by C is 1, but I do not write 1 because 3 times 1 is just 3, and x divided by x is just 1. So that is the answer. 5cx a plus 3. Okay, what about this one? 3x to the power of 4, y to the power of 4, minus 21 x to the power of 5, y to the power of 2. Okay, so yeah, from numbers, this is 3, this is 21. Is there any common factor between 3 and 21? 3 itself. So from numbers, I pull a 3 out. X appears here with 4th power. X appears here with 5th power. x4, yes? So I take x to the 4. And then y appears with the 4th power, 2nd power. So I have to pull y squared out. And I don't think it is really hard. I think you can just do it in your head. So what's the answer left? Y squared minus 7x. Thank you. So what is left for me is this one. So that's the factorized form of that expression. You might ask why we have to bother about factorization in the first place. I will be able to answer this partially for you. There are two main reasons that we want to factorize that I will talk later. But try to focus on doing that. Trust me that we need it, so try to learn this in a proper way now. So another one. So let me write minus 3ab and minus 2b squared c minus plus ab squared. So if you want to factorize this, can I factorize something out? The numbers are minus 3, minus 2, and what is not written here is 1. So apparently I do not have any numbers in common, so forget about numbers. But do you see any letter part in common? Only B. Be careful. So A is here, but not here, but it is here. So it is not a common factor. It is only common to these two, but not all of them. So it is not considered as a common factor. Common factor means a factor which is common to all of them. So A is not a common factor to the whole expression. For the same reason, C is not a common factor. And then B is. But what is the highest power of B in common? 1, because it appears by 2 here, but here only appears 1 times, yes? So this means that there is only one thing that I can pull out, and that is just B. And then, okay, tell me what is left. Minus, be careful, you have to put this minus sign. Minus 3a. Which sign? Minus 2bc plus ab. That's it. So this is the factorization of that form. Okay, let me give you another example. So 44 x to the power of 3y minus 77 x to the power of 2y minus 66 x to the power of y and z squared. So if you don't mind, let me put a z here as well. yz. Yes. So what should I write here? Yes, from these numbers, this is not hard to see that they share 11 in common. Yeah, so this is 4 times 11, this is 7 times 11, and that is 6 times 11. And 11 is the highest number that you can pull out. Yes. So let me just write 11. I pull out. From letters, x is here with power 3, here with power 2, here with power 2. So that what is the highest one that I can pull out? X squared. Okay, and then from y, just 1y. What about z, by the way, here? Yes, because even though z is common between these two, but it is not common for all of them. So you have to just open a pair of brackets in front and write. But how should I write? If you do it fast, that is quite good. But what is the rule? The rule is to divide. Be careful, not subtract. I divide this in my head by this expression that I pulled out. 44 divided by 11 is 4. X to the 3 divided by x to the power of 2, x is left. Y divided by 1 is 1, which I don't write. And then what is the next one in your head now? Z. And then minus 6 z squared. So this is the factorization of this expression or polynomial. Okay. This is good. But now there is also some kind of examples. These are a little bit higher level ones, but I want you to understand that. I told you that why we factorize mainly because of 2 reasons. One reason is simplification of rational expressions, of fractional expressions. Why is that? For example, if I ask you to simplify this, every one of you can do it under 1 second, hopefully. So if I ask you, can you simplify this? You would say that I rescale it by 5 or divide everything by 5. So this answer becomes 3/5. 4. So you could do it quickly, but if you go back and check what has happened in your brain, the reason that we can do it, by the way, that's extremely important to listen here. The reason is that in principle, you factorize 15 in your head. What is 15? It's 3 times 5. And then you factorize this 4 times 5, for example. And then you take the common factors out. And then the answer becomes 3, 4. But because this problem is so simple, you even don't think about factorization. You are factorizing in your head, but without even noticing it. But this is a very important. I have seen many mistakes. Some of them, I have seen even some university students sometimes make mistakes. The only thing that you can take away is a common factor. You are not allowed to take away common summands. For example, so I hope that you realize that here, if I give you this expression, you are not allowed to take 3 out. This is extremely important. I have seen some students make over and over this mistake. So 3 is not a factor, it's a summand. If I ask you what is the role of 3 for the denominator, you shouldn't say 3 is a factor of the denominator. 3 is a summand of the denominator. The same story. You are not allowed to simplify summands from the numerator and denominator. You can only simplify factors that are in common. So do you know the difference between summand and factor? Here 3 is a summand because it is added to 4. But here 5 is a factor because it's multiplied by 3. So remember this very rule of thumb, that whenever you want to simplify something from the numerator and the denominator, you are only able to do it if that expression is a factor. And this is why factorization is important. Because if I want to cancel something out, first I have to write this as a product and write this as a product and then find the common factors to cancel out. Writing this as a product means factorization. Writing this as a product means factorization. So in algebra it becomes extremely important. For example, this very nice problem in the book, let me simplify this. 8a squared minus 20ab. This I'm just copying and pasting from the problem in the book. And I'm supposed to divide this by 12a. Okay, so that is what, let me explain this because I know that you probably, it doesn't matter how many times I explain, but you might make mistakes in the future. This is an algebraic expression. So it was so quick here, it was so easy that you really don't bother to write this intermediate step. You can just do it in your head and give the answer. But then the problem, this is one of the simplest possible problems. You can make these kinds of problems extremely hard. So you cannot guess what can I do. But what I want you to understand, you are not allowed to take this out with that a. This is not acceptable. Why? Because a is a factor, you are right. Because this is already a product, so a is a factor. But a is not a factor of the whole expression. A is just a factor of this part, not the whole expression. Okay? So you are not allowed to take a factor of the denominator with a factor of one part. You can only take those factors that are common to the whole numerator and the denominator. So I want you to understand, this is not possible. Okay? Am I allowed to divide this by, to simplify this 12 by 4 and this 8 by 4? Am I allowed to do that? This 12 by 4, this 8 by 4. Yeah, if you do the 20 as well, but I just say 12 and 8. No, because 8 is not a factor of the numerator. It's just a factor of this part. Okay, so what you need to do, the first step, which is one, you have to write it down by the way, I need to think about factorization. 12a is already in its factorized form, so I don't need to do anything with it. But then I factorize the numerator according to what you just learned. Okay, what can I pull out? The maximum factors that I can pull out. From 8 and 20, 4 is the highest value of. Between the factors, I have 2a's here, 1a here. So the maximum a that I can pull is a, and then that's it. So what's left here now? 5b. Okay. Now, if I ask you what are the factors of the numerator, you would list them. One of them is a, 4. The other one is, no, 2a minus 5b as a whole is just one factor, yes? And if I ask you what are the factors of the denominator, 12, which and then a. But 12 itself is what? 3 times 4. So what are the common factors now? A is in common, not this a with that a. It's extremely important. This a and that a are in common. This 4 and that 4 are in common. So then I am allowed to simplify. I divide this by 4 1 times. I divide this by 4 3 times. Is it allowed? Yes, because these are factors. This a with a 1 times. This a with a 1 times. Is it allowed? Yes. But what is left? In the denominator 3 and 1, which I multiply them back, it becomes 3. And 1 times this expression, which is 2a minus 5b. But I don't need any pair of brackets anymore. The pair of brackets was needed because I had something before that. But now everything is simplified, so why should I bother to write this down? That's the answer. You cannot continue. So what about if I had this situation? For example, if I give you this, can I simplify this more? Yes or no? No. Because you might say that, yes, I can simplify this, but there is no, because if I ask you, is 3 a factor? You would say, yes, this is the whole expression. But is 6 a factor? No, it's a factor only for this part, not the whole expression. You can only simplify factors for the whole numerator and the whole denominator. Okay, let me solve some of these problems. So this is one reason that we are interested in factorization. So everyone hopefully agrees that working with this many, with this expression is harder for our brain than working with this expression. Yes, because this is simpler. When it comes to numbers, because you have calculator in front of you, you might don't appreciate that much about these simplifications because the calculator will do the job for you. Okay, but you need more advanced application to be able to do these algebraic expressions right. Okay, so the normal calculator usually do that. Okay, so that's extremely important to understand that simplification of algebraic expressions is a main task that you need to improve your skills about this. And this I answered the question. If someone asks you why we bother about factorizations in the first place, one answer is this: if there are fractional expressions, algebraic expressions, not numbers, in those cases, if I want to simplify that, the best thing to do is to factorize. Okay, let me solve 1 or 2 problems from the book, and then this lesson is finished, and I will give you time to practice on your own. So there are good questions here, even some level 3 problems. But let me solve one. This is the problem in the book 2163. The part A is easy. Let us just do part B together. Part B. Okay, so the question is that simplify the expression as much as possible. So the expression is this: 40 x to the power of 3 y minus plus 28 x squared y squared minus 36 y to the power of 3, and then you have this divided by 12x to the 4 y to the 4. Okay, so we want to simplify this expression. So let me double check that I have written everything according to the book. Yes, that's correct. So if I ask you to simplify this expression, what you need to do is that to factorize the numerator and the denominator separately according to the rule that we just learned. For the denominator, I don't have any problems at all because it's already written as a product. So it is in factorized form itself. So don't change anything at all. But in the numerator, first of all, between 40 and 28 and minus 36. What is that? 4. And from letters, x to the power of 3, x to the power 2, nothing. So what is that one? X is not in common. But what about y? I take one y out. So what is left from the first one? 10x cubed plus 7x squared, but y minus 9y to the power of 2. Yes? And then if I ask you, this is not possible to continue anymore. So the numerator has 3 factors. One of them is very simple, 4. The other one is also simple, y. But the next one is a little bit more complicated. So the whole package is just 1 factor. Okay? But the denominator, I have 12, 4 factors of x and 4 factors of y. So I can simplify only factors. For example, can I simplify this 4 and 12? Yes, because they are common factors. So this becomes 3 times, and this becomes 1 times if I divide. And this 1y, I can take this out. How many y's are left? 3. But the answer becomes 1 times 1, which is nothing, which has become 1. Nothing is wrong, sorry. 1 times this expression is just that expression. Do I need pairs of brackets? No, not anymore. If you write, that's not wrong, but why we should bother to write? And then I have this divided by 3 x to the 4 y to the power of 3. So that's the final answer to this question. No, we cannot do that. But let me also solve one level 3 problem. So that is, we can solve 2 of them together. Okay, so let me solve this problem, 2165. Let me solve part A and D. Okay, so this is part A, the simpler one first. So 15a squared minus 6a divided by 5a minus 2. So, is it in, can you factorize something more here? Because this contains 5 and a, this is just 2, so we cannot factor. So we have to live with it. So this is nothing we can do. But this is a little bit different. So that is a subtraction itself. What about the numerator? Can I factorize a number out? 3 and a, yes? So what is left? 5a minus 2. The reason that they call it level 3 is not because it is hard. They want you to understand. Yeah, you just need to read the factors. What are the factors? 3a and the whole package 5a minus 1. But 5a minus 2 is the only thing that appears in the denominator. When you have one single expression, that expression can be considered as a factor of itself. Yes? So this means that, am I allowed to take this and that away? Yes. So the answer becomes 3a. When you divide, this becomes 1. This becomes 1. So this becomes 3a times 1 divided by 1. But no one bothers to write 3a over 3a over 1 because there is a better name for it. What's that? It's just 3a. So everyone agrees that working with 3a for our brains is much simpler than working with this one. So that is the simplification. That's why it's important. Okay, so let me solve part D as well, and then the lesson is finished. So part D, by the way, this is coming in the test, okay? So that the test comes until the end of this lesson today. Okay, so 2165, part D. So I want you to see this. I have 16a cubed b minus 18a squared b squared divided by, I have 36ab minus 32a squared. So we want to simplify this as much as we can. So I hope that you see that none of the cancellations are possible at the moment. So you shouldn't be tempted to take this A with that A off. That's not possible. I want you to see A is not a common factor in this way that you see. For the time being, A is not something in common to the denominator. You have to pull it out and make it transparent. Okay, so let us just do that because you already know what to do. So in the numerator, I start factorizing as much as I can. From numbers point of view, 16 and 18, 2. So I will take 2 out. From letters A squared, and from B, just B. So what is left for me? A single, no, from numbers, 8. A, that's it. And from numbers there, minus 9 and B. So far, so good. Okay, so let us just make it a little bit better. So the denominator, what can I pull out? From numbers, I can pull 4. From letter A, just 1A, nothing else. So what is left for me? B, A. Okay, so that let me put a star here because this is something I want you to pay attention to it. This is the problem. From 4 and 2 I can simplify because I can simplify by 2. From A's I can take 1A out, B is left. But do you think I can take this out? Yes or no? Yes. So they are not the same. So you can only pull out the same factors. Okay. But the difference is quite small. That's not a big difference. So that's why I put a star here. If you write it in that way, what you need to take, you take 2 and 4 out, so 2 is left. A and A out, A is left and B is left, and 8A minus 9B and 9B minus 8A. In this way, this is the final part of the problem. You cannot continue anymore, yes? So I simplified 2 with 4. 1 is left here, 2 is left here. I took this A away from here and there, and A and B are left, and I put this one and that one, yes? But the point is that we can do better. Can you say how? They are not the same thing. First of all, do you agree they are not the same thing? Because 2 minus 3 and 3 minus 2 are not the same numbers. It is not commutative. You cannot replace them. But the big problem is that it's not a very big difference. So whenever this happens, this I want you to teach the trick. So you realize that this is not a big difference. So instead of factoring in this way, I pull minus 4A out. Okay, this sometimes happens in algebra, which you cannot see it in numbers. Okay, so let me ask you again. Instead of factoring, I couldn't foresee this is happening. So I just did it normal way, and I realized that I cannot continue any further. Okay, now I change, but I realize the difference is just a minus sign. So instead of pulling 4A out, I decide to pull minus 4A out. Okay, so let us see what happens. Now, can you factorize it again for me? Because you divide this by that, what is happening? It's minus 9B now. And that the other one becomes what? Plus 8A. Yes? So is this and that exactly the same? Yes, because this is positive 8A, minus 9B, minus 9B. So by this trick, sometimes I want you to understand, sometimes we just pull a minus sign extra whenever this is happening. And now, if I continue simplification, this expression can be completely cancelled out with this expression because they are exactly identical now. And they are factors, common factors. And the same the rest of the story. So what happens? 2 and minus 4. It's minus 2 left in the denominator. A and A squared are gone. A is left and B is left. Yes, so that's the answer. And hopefully you agree this is much simpler to work with than the previous one. The previous one was partially simplified, not completely. But this is the complete simplification. And then that's up to you to put this minus sign here or there or in front. I myself prefer to put it in front, but if you stop here, that's completely acceptable for me. So this expression, which is probably a hard one, there is no difference between this expression and just that expression at the end. So working with this is actually very more efficient. Yes, please. So I told you that if you have a common factor, you can take it out. So now if I ask you, is this the same as this expression? You would say yes, because 8a with positive sign, 8a with positive sign, 9b with negative sign, 9b with negative sign. So there is no difference between this expression and that expression. On the other hand, is this a factor? Yes. How many factors you see in the denominator? 3 of them. One of them is -4, the other one is a, the other one is the whole combination. How many factors you see in the numerator? 2, a squared, which is 2a's, and 1b, and then this expression. So this expression is a factor for numerator and denominator. When this happens, you can take it off. Yes? Any questions? Okay, so I stop here, and you can start working. I will complete the Google Classroom a little bit, so the test will be covered until the end of lesson today. Okay? Tomorrow I will continue teaching, but that part will not come in the exam. Okay? And as I told you that on Friday and Monday next week, I will give you time to practice if you have any questions, and then we have the exam on Tuesday. Thank you very much.